Hello biology, and welcome to a video going over diffusion, osmosis, and how how cells respond to different environments. You have this note sheet which will mostly be based on drawings, and I will go over the drawings that you should have done or should do at the end of this video. So let's get into it. In terms of our cells, which are the smallest unit of living things in our body, we have this concept of the internal and external environment. And then the question then comes to, how do we get things in and out of our bodies? So whether it's food or oxygen or hormones or other molecules, how do we get things in and out of our cells? And the cell membrane, which we're going to talk a lot about over the next 2 weeks, is the enforcement mechanism for regulating how molecules get in and out of our cells. So diffusion is going to be the first concept we talk about with this sort of mini unit, and it's just the movement of molecules from one space to another. So you diffuse into my classroom every day for biology, and then you diffuse out. And diffusion is always going to happen passively, which means without energy, without any mechanism from high to low. So you are all out in the hallway at the beginning of class and you flow into my classroom, and then your concentration is higher in the classroom. So then you will leave my classroom at the end of the period. So if we have a bunch of molecules outside of our cell, they're going to want to go into the cell because of their difference in concentrations. And I have a couple more pictures to show you of that. Because of the mechanics of the cell membrane, and more on that in a few slides, smaller molecules always get through the cell membrane faster than larger ones. They can flow through the spaces and the different biochemical properties of the cell membrane much faster. And less polar molecules will also diffuse faster through the membrane. The less polar you are, the fewer attractions or hydrogen bonds or repulsions that you will feel between yourself and other molecules. So being quiet, being nonpolar, being uncharged means you can get in and out of these molecules much faster. So what does diffusion look like? If I have two molecules, orange and black, they are going to diffuse throughout this space until they reach equilibrium or reach roughly the same concentration of oranges everywhere and blacks everywhere, meaning they're going to go from high to low, and they're going to spread out. And diffusion is random. It isn't like soldiers marching in a line. It's not a fire drill. But it is based off the concentration differences of a molecule in a high environment and a low environment. All of these molecules are just wandering randomly, and they are going to spread out over time. And we can see that again, where just one molecule is going from high to low. And again, this movement is random. It will increase with temperature. If we make it hotter, these molecules will move faster. If we increase the concentration, they will spread out quicker, and there will be a larger change in their rate over time. But diffusion, again, is just the movement of molecules from high to low. So in terms of the cell membrane, this is what it looks like. This is a cell, and this is the cell membrane. It is a bilayer of phospholipids, and I'll talk about what that means in just a second. But what is the concept or the purpose of the cell membrane? It's basically to regulate an internal environment that is either consistent or can react to changes in appropriate manners. It's like a house. It regulates the internal temperature of your house. It's like a school. It regulates who can get in and out of the school. Students and teachers, yes. Scary strangers, no. And it's meant to create a separate and unique space relative to the outside environment. And that's really important for a lot of different cells and tissues in our body. It makes specific cells have really specific roles and very specific functions. So for example, neurons will fire and cause you to react because of the membrane making your neurons be specific and specialized. Your muscle cells and your liver cells will store food energy because those are the cells that have an internal environment designed to store your lunch. Your immune cells, your B cells, your T cells, your macrophages, they'll all respond to illness because they have an internal environment that's designed to do those sorts of tasks. Your lung cells are really good at absorbing oxygen because of the internal environment in your lung cells relative to oxygen in your lung cavities. So that is to say, in a very specific and nerdy way, that the cell membrane is really useful for creating specific cells with specific roles that do things for our bodies. And without the cell membrane, those roles would be really lost, right? Before the walls in the school up in the library, you could hear 5 different teachers talking about 5 different subjects, and it could be very confusing. So, the cell membrane itself is made up of 2 layers of phospholipids, and phospholipids are a hybrid molecule. There is a phosphate head at the top of a phospholipid, which has this POOO. Don't worry about the 5 bonds. We don't need to know why that happens, but that is a very polar molecule. And then 2 fatty acid tails that could be saturated or unsaturated that are in the interior. And these guys are very nonpolar, and they are what helps repulse large and polar molecules due to their nonpolarity and also how they pack and condense into that space. So to better understand the structure of a phospholipid, I want you guys to draw this phospholipid right here in the space. This should be pretty easy. All the O's, the CH2. So again, this is where you're going to have an H here and an H here, CH. So put that H there. You're going to put all of these molecules and atoms in your structure, and then have 2 fatty acid tails coming down. I believe that you want to make one of them C5H11 and the other one C5H7. So this is going to be unsaturated, and this is going to be saturated. Make sure you show all polarity within the molecule based on charges. So, in terms of the basic mechanics of how this regulates things coming in and out of our cells, let's refresh and talk quickly about hydrogen bonds, which are a new concept we learned this week. Again, hydrogen bonds are when 2 molecules with positive and negative charges can interact. And the most common example is going to be hydrogen atoms in polar bonds that interact with lone pair electrons in another molecule, often oxygen or sometimes nitrogen. These bonds are weak, they're transient, and it's based on 2 molecules with opposite charges that are just attracting. And we know that water is really good at forming H bonds because a water molecule is nothing more than an oxygen with 2 pairs of lone electrons and 2 hydrogens. So again, positive and negative attractions are really important for understanding the environment within cells, but also how different molecules interact. Which gets us to the first idea, and just one more idea to revisit. Ionic compounds, again, salt molecules, are really positive or negative because on how they've lost electrons. So again, the complete loss of an electron from sodium to chlorine based on their electronegativity is what causes salts to be really charged and very good at attracting water molecules. So, with all of that revisitation or regurgitation or whatever you want to say, let's talk about some new ideas. The first one is going to be that the concentrations of molecules that interact and dissolve in water influence how water moves in and out of the cells. And this is really important because cells need a lot of water to do a lot of different reactions in our bodies. They're really important for building molecules up and breaking molecules down. And we can influence how water comes in and out of our cells using salts or sugars dissolved in cells. The movement of water in and out of cells is called osmosis, and it's always based on molecular concentration. So there's 3 different types of environments that can exist within cells or outside of cells that influence how water moves. The first and the easiest one is isotonic. And isotonic is when there are equal amounts of sugar and salts relative to water in and out of the cell. So basically, the amount of charged molecules inside of the cell are equal and proportional to what is out of this what is outside of the cell. Basically, movement of water is going to be at equilibrium. We also have hypotonic, and hypotonic is going to be when water flows into the cell at a higher rate. So 4 arrows versus 1 arrow. That is because there is a high solute pressure or more dissolved molecules in the cell than outside of the cell. So water is going to be attracted to those charged bonds, those potential hydrogen bonds, and it's going to cause the cell to get big. I usually remember hypotonic because it makes the cell swell like a hippo. And then we have hypertonic solutions, and that's going to be when the net movement of water, the overall water movement, is going to be out of the cell, and that's because there are more dissolved solutes or dissolved molecules in the solution outside of the cell. And that's going to cause cells to shrink, which is why I remember hypertonic. It sort of makes the molecule get smaller. And that's going to be how water moves in and out of our cells based on those attractions. Water is polar. We go back. Water is very polar. Positive, negatives in all of the different directions. The 2 pair of lone electrons, the hydrogen, all of water wants to make bonds. So it will be really attracted to different charged molecules in and out of the cell. So to further illustrate that, let's take a look at 2 different environments. One environment has a lot of dissolved sugars, and the other has basically free distilled water. I need to go back right now and make this a hydrogen bond. Let's make it green. That way we're not confused. We have hydrogen bonds existing between all of our water molecules. Again, a water molecule can have 4 hydrogen bonds between its 2 pairs of electrons and the 2 hydrogen atoms within it. This is what we would call distilled water or free water. All of the water is just chilling all by its own. Inside of the cell, or on the other side of the environment, we have a high amount of dissolved molecules. We have water, but we also have a lot of COHs or carbohydrates. This is a hexose or a 6-sided carbohydrate, so it's going to be glucose. This has a very strong osmotic pressure on the cell. The water is going to be attracted and flow into the cell because of all of these potential charges that it could interact with. It's more exciting, it's more charged, it's more potential to have different attractions inside of the cell on this side, so water will flow into the cell. So I want you on this image to not only draw these 2 relative environments, but also draw this glucose molecule. This is the thing that is attracting water into the cell or moving into the left environment. This is a glucose molecule, so we have 1, 2, 3, 4, 5, 6 carbons, 1, 2, 3, 4, 5, 6 oxygens, and 12 hydrogens. What you want to do for this molecule, which you can gladly copy down, is label polarity, 2.5, 3.5, 2.2, but also circle any possible place where water could dissolve or influence or interact with this molecule based on hydrogen bonds. And you will find that there's probably going to be 18 to 20 different bonds that could happen in this molecule, meaning there's a high potential for water molecules at any given time to attract to this. The bigger you are and the more polar you are, the more likely you will attract water into your space because of hydrogen bonds. So, in a nutshell, if we want to go back and revisit what we've talked about, diffusion again is just the movement of molecules in and out of the membrane. We use phospholipids as a dual mechanical molecule to regulate what goes in and out of the cells through the membrane. More on that with our lab next week. We know that hydrogen bonds are positive, negative attractions, and that water will flow in and out of the cells based on different concentrations of molecules that have charges. I hope this has been helpful. Come in with questions, and I will see you soon.